Okay, number 51 from 11.2. They're asking us how many distinct permutations can be formed using the letters of the word Tallahassee. So the way to figure this out, distinct permutations, is we're going to make a fraction. And the top of the fraction is going to be a factorial. And to figure out what factorial that is, we need to count all of the letters in the word. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So the top of our fraction is going to be 11 factorial. Now for the bottom of the fraction, the question's asking for distinct permutations. That means that the double letters and I guess triple letters in here are going to cause a problem because they won't make distinct permutations. So we need to take those into account. So we need to go through and find any letter that shows up more than once in the word. And what I'll do is I'll just cross off each of the letters as I deal with them. So T only shows up once. I don't have to worry about that. A, I have 1, 2, 3 A's, so I'm going to put a 3 factorial in my denominator to account for those 3 A's. Cross them out so that I know that I've dealt with them. How many L's do I have? 1, 2. So I'll put a 2 factorial in my denominator to deal with those 2 L's. How many H's do I have? Just 1, I don't have to worry about that. How many S's do I have? 2. So I'm going to put a 2 factorial in the denominator to deal with those 2 S's. And finally, I have 2 E's, so I'm going to put another 2 factorial in the denominator to deal with those. Okay, so anytime you have a letter that shows up more than once, however many times it shows up, put that factorial in the denominator. And now we can figure this out. So we could plug it, it's my cell phone, you don't want my cell phone, we want my calculator. Let's plug this into our calculator, and since we've got so much going on downstairs, how about we plug in what's in the denominator separately? So the first thing I'm going to do is 11 factorial. And remember, factorial is under the probability button, arrow over to the exclamation point, and you get factorial. 11 factorial, holy smokes, that's a big number. That's 39916,800. Okay, and now in the denominator, we're going to enter 3, go over to factorial, times 2 factorial. But what's 2 factorial? 2 factorial is 2 times 1, so 2 factorial is just 2. You can save yourself some time. You don't have to type in 2 factorial for each of these. This is just the same as 2 times 2 times 2. And so that gives us 48 in our denominator. So let's go ahead and divide that and see if we can reduce it, which I'm pretty sure we can. Since what we're looking for is distinct permutations, it should actually come out to be a whole number. So we get 39916,800 divided by 48, and the answer is 831,600. Oops, 0. Okay? And so that's our answer there. So to figure out the number of distinct permutations using the letters of a word, what we do is count up the letters, all of the letters, and put that number factorial in the numerator. Then we look for any letters that show up more than once in the word. If it shows up 3 times, like the A did in Tallahassee, we put a 3 factorial in the denominator. If it shows up twice, like the L, the S, and the E, well, we put 2 factorials for each of those in our denominator. And then we just multiply everything out, simplify, and we come up with 831,600 distinct permutations that can be formed using the letters of the word Tallahassee.